Okay guys, so let's talk about the JEE main pattern exercises for matrices. First question says that you are given a matrix A, then A square is I, that is identity matrix of order 2, is true for what theta? Okay, so talking about A square, if A is given to you as cos theta, sin theta, minus sin theta, and again cos theta. If you take its product with itself because you want to compute A square, you again write the same matrix. What is it that you get? Over here, what is it that you will be getting? See, cos square theta minus sin square theta is cos 2 theta. Then you have cos theta sin theta plus sin theta cos theta. Sin A cos B plus cos A sin B. Sin of A plus B, sin of theta plus theta, sin of 2 theta. Again, minus sin theta cos theta minus cos theta sin theta, which is minus of sin A cos B plus cos A sin B, where A and B are theta. This is minus sin of theta plus theta, that is 2 theta. And then you have minus sin square theta plus cos square theta, which is cos square theta minus sin square theta, which is cos 2 theta. So this is basically A square. A square is equal to identity matrix of order 2, that means it is equal to 1, 0, 0, 1. Now two matrices are equal when each and every component of them is equal. Cos 2 theta is equal to 1, sin 2 theta is equal to 0. Sin 2 theta is 0. Now what is that angle? That same angle at which cos is 1 but sin is 0. You know that angle is only one angle which is 0 because sin 0 is 0 and cos 0 is 1. So you get 2 theta is 0, which is theta is 0 degrees. It is for theta equals 0 that this matrix A, when you square, you get identity matrix. Cool? Next question says that AB is A and BA is B. Okay, where A and B are square matrices, then which one is going to be true? The question is basically upon A square is equal to A or not, B square is equal to B or not. Talking about A square, this is A into A. A can be written as A into B because A into B is given as A. A into B into A. By associativity, I can write it as this. But B into A is given as B, so I get A into B. But A into B is again given as A, so I get A square is equal to A. Similarly, talking about B square is B into B, right? B is nothing but BA into B. By again associativity, I can write it as this, but AB is A and BA is B. So B square is also equal to B. So you are getting that A square is A and B square is B. Then next question says that A is given to be this matrix of order 2, iota 0, 0, iota, A to the power 4n is equal to what? Over here basics come into picture. You don't need to multiply A with itself 4n times for any n, but because this is a diagonal matrix, even A to the power 4n is a diagonal matrix. Whatever power this particular matrix is raised to, that power is only attached to these diagonal components, right? Therefore, A to the power 4n is nothing but iota to the power 4n, 0, 0, iota to the power 4n. You know iota to the power 4 is 1 and 1 to the power n is 1. So this gives you 1, 0, 0, 1, and this is your answer. Just the concept that when you talk about diagonal matrix, raise it to any power, the answer is still a diagonal matrix and the power basically gets attached to just the diagonal components, right? Next you have if the matrix AB is 0, so A into B is 0, then which one is true? So we've done this in the theory sessions as well. Very, very nicely. You can just directly see the concept is being asked. If the matrix AB is 0, then is it true that A has to be 0 or B has to be 0 or both have to be 0? What is the scenario? If you remember, I had told you if you take these matrices and you multiply, you get 1 into 0 plus 0 into 0. This is 0. 1 into 0 plus 0 into 1. 0 into 0 plus 0 into 0. 0 into 0 plus 0 into 1. So you can see this matrix is not a null matrix. This matrix is not a null matrix because all entries are not 0, but still their product is 0. That means product of two matrices is 0. That doesn't mean one of them has to be 0 or both of them have to be 0. No. It's written all the above statements are wrong, but first statement is correct, that it is not necessary that either A is 0 or B is 0. Like over here. Both are non-zero, but still the product is 0, and therefore D is also wrong. Fine. Direct usage of concept. Next question says, if A is this, then value of determinant of adjoint of A is what? Again, very, very direct use of the concept. What is determinant of A? Because A is a diagonal matrix of order 3, you know that determinant of A is nothing but the product of its diagonal entries, which is alpha into alpha into alpha. If you don't know this, you will have a tough time dealing with this question because it's going to cost you a lot of time. Determinant of A is alpha whole cube. Then what is, or it's not alpha, this is small a, so let me write it as small a cube. What is determinant of adjoint of A? It is determinant of A to the power n minus 1, where n is the order of matrix A. But here order of matrix A is 3, so this will be equal to 3 minus 1, which is determinant of A to the power 2. Determinant of A is A cube, to the power 2 is A to the power 6. Clear? And that is your answer. Just use the concept that because A is a diagonal matrix, therefore determinant of A is the product of all the diagonal entries. The moment you have determinant of A with you, determinant of adjoint of A is nothing but determinant of A to the power order of matrix A minus 1. Order is 3, so determinant of A to the power 2, that is A to the power 3 to the power 2, which is A to the power 6 is the answer. Then next question we have that there is a matrix. It's been asked, is it a symmetric matrix? That means, is A transpose equal to A? Is it skew symmetric? That means, is A transpose equal to minus A? Is it Hermitian? That means A conjugate transpose is A. Or is it skew Hermitian? That is A conjugate transpose is minus A. What is true for this particular matrix? So if you can directly analyze, when I am going to take the transpose, of course it is not going to come out to be equal to A. If it is not going to come out to be equal to minus A as well, right? So the question is about conjugate transpose. If I take conjugate of A, it is minus iota, 1 plus 2 iota, minus 1 plus 2 iota and 0. And now when you take the transpose, it is minus iota, 1 plus 2 iota, minus 1 plus 2 iota, 0. This is not equal to A, you can see it. It's not equal to A, therefore it's not Hermitian. But if I talk about minus A will be minus iota, minus 1 plus 2 iota, 1 plus 2 iota and 0. And you can see both these are equal. Therefore, you are getting that the transjugate of the matrix A is equal to minus A, and therefore A is skew Hermitian. Fine? Now, next question says if A is this matrix, then the matrix A, regarding the matrix A, which of the following is true? Okay, so talking about A inverse exists or not, I will have to talk about the determinant of A. If the determinant of A turns out to be 0, inverse does not exist. If A turns out to be a non-singular matrix, only then the inverse exists. So here if you can see very easily, if I am going to take out the determinant, it is going to come out to be just -1 because these two components are 0. I am expanding along the first row, -1, 0, -1, which is 1 not equal to 0. So I can definitely say A inverse exists. And so this is wrong. -1 times identity. If I talk about -1 times identity matrix, it is actually 1 0 0 0 1 0 0 0 1. If I want to talk about 3 cross 3, so 1 0 0 0 1 0 0 0 1 when multiplied by -1 gives me -1 0 0 0 -1 0 0 0 -1, and this is not my matrix A. The off diagonal entries are -1, but over here the main diagonal entries are -1, so both these matrices are not same. So this is wrong. Obviously A is not a null matrix, and A square therefore is equal to I. This is correct. In fact, you can do it also when you're going to square the very matrix A, you are going to get identity matrix. Clear? The next question says, A is this matrix. Now the speciality of matrix A over here, as you can see, is that it is an upper triangular matrix, right? Because it is an upper triangular matrix, you should know that determinant of A is just equal to the product of these diagonal entries, right? Determinant of A is 5 into 5 into alpha, which is 25 alpha. It is given that determinant of A square is 25. You should know that if A is the square matrix of order n, then determinant of A to the power n is determinant of A whole to the power n. So basically what I am trying to say is determinant of A square is determinant of A whole square. Determinant of A square is 25, determinant of A is 25 alpha whole square. You are going to get alpha square is 1 by 25, alpha is 1 by 5, and that is what is your answer. Fine. So easy enough question, only the concept used is that if you have an upper triangular matrix, then the determinant will be the product of its diagonal entries. A and B are square matrices, okay, such that the tranjugate of A is A and tranjugate of B is B, then AB minus BA tranjugate is what? Okay, so AB minus BA tranjugate means AB minus BA, first conjugate and then transpose. Conjugate of difference of two matrices is difference of conjugate of those two matrices. So I get AB bar minus BA bar transpose. AB bar, you know that conjugate of the product is product of the individual conjugates. See, so many properties are being used regarding transpose and conjugate. This shows you what? Transpose gets distributed over the subtraction sign. You get A transpose, B transpose, or A conjugate, B conjugate whole transpose minus B conjugate, A conjugate whole transpose. Then over here again the property of transpose is used. B conjugate transpose, now this is going to come first. A conjugate transpose next, minus again reverse order, A conjugate transpose, B conjugate transpose. This is tranjugate of B, so this is B star, A star minus A star, B star. A star is given to be A, B star is given to be B, you get BA minus AB. BA minus AB, which is option number C. Fine, so I've used all the properties of transpose and conjugate and the very condition that A and B, they have their tranjugates equal to themselves. That is being used to actually get this answer. Then it says that consider the system of equations in XYZ as this. If this system has a non-trivial solution, then for any integral values of integer n, values of theta are given by what? Now if you can see, this is a homogeneous system of equations, right? and one thing is given, that it has a non-trivial solution. This can only and only happen if you have a homogeneous system of equations, linear equations in n unknowns. It can have non-trivial solution only and only when the coefficient matrix is non-singular or singular. Yes, it is singular. When the coefficient matrix of this is non-singular, you get a unique solution which is a trivial solution 0, 0, 0, x0, y0, z0. When it is trivial, that means when it is singular basically, then you get non-trivial solution. So, if it is given to you that you are getting a non-trivial solution, means the determinant of the coefficient matrix is 0. So, determinant of sine 3 theta minus 1, 1. Then you have cos 2 theta 4, 3. Then you have 2, 7, 7. This is 0. Expand. Sine 3 theta, 28 minus 21, that brings it to 7, minus of minus 1, that is plus 1, you get 7 cos 2 theta minus 6, then you have plus 1, 7 cos 2 theta minus 8. Okay, so you get 7 sine 3 theta plus 7 cos 2 theta plus 7 cos 2 theta, so it is 14 cos 2 theta minus 6 minus 8 is this. Fine. You can see 7 can be brought out common, so you have sine 3 theta plus 2 cos 2 theta minus 2 is 0. Sine 3 theta is what? 3 sine theta minus 4 sine cube theta plus cos 2 theta is what? 1 minus 2 sine square theta into 2, that gives you 2 minus 4 sine square theta minus 2. Minus 2 plus 2 gets cancelled, sine theta can come out common. What are you left with? You are left with 3 minus 4 sine square theta. 3 minus 4 sine square theta minus 4 sine theta. Or you can write it as sine theta 4 sine square theta, 4 sine square theta plus 4 sine theta minus 3 is 0. Break the middle term, you get sine theta. Inside you have 4 sine square theta plus 6 sine theta minus 2 sine theta minus 3 is 0. Right? That gives you 2 sine theta common. 2 sine theta common, you are left with 2 sine theta minus 1 minus, or let me say plus 3 2 sine theta minus 1 is 0. So, you have sine theta 2 sine theta minus 1 and 2 sine theta plus 3. This obviously gives you theta is 0 or 1 by 2. I am not taking negative values because from 0 to pi sine is not negative, and I want theta which are basically varying from 0 to pi. So, over here this means what is the very value of theta in terms of integral values of n. This means theta can be n pi, because at every multiple of pi sine is 0, or theta is equals to n pi plus minus 1 to the power n into pi by 6. This is the general solution of sine, sine theta equals half, right? Sine theta is equal to 0, sine theta is equal to half, sine theta equals 0 when theta is n pi, sine theta equals half when theta is n pi plus minus 1 to the power n into pi by 6, right? And over here you are given this, n pi plus minus 1 to the power n into pi by 6. Clear? So practice all these questions very nicely. That's it from my side. Thank you.